Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The pK of ACH bond reflects the stability of the carbanion formed upon deprotonation. A lower pK means greater acidity, i.e., the carbanion is more stable. Moving on to the next step. Identify the acidic CH in each compound. A. Triphenylmethane, pH 3C, H. The sp3CH is stabilized by resonance delocalization into 3 phenyl rings. pK 31. B. Diphenylmethane, pH to CH to the sp3CH is stabilized by delocalization into 2 phenyl rings. pK 43. C. 9-phenylfluorine, the C9H of fluorine is already part of a 5-membered ring flanked by 2 benzene rings. Upon deprotonation, the carbanion achieves 14-pi-electron cyclopentadienyl-like aromatic stabilization across the fluorenyl system plus an additional phenyl group. pK 18. D. The compound in option D is a fluorine core fused with 2 additional benzene rings, a tricyclic aromatic system with a cyclopentadienyl type sp3CH, making it structurally analogous to indeno 1, 2, 3, CD, fluorine or a related system. The sp3CH sits at the junction of multiple fused aromatic rings. Upon deprotonation, the resulting carbanion is delocalized over an extended polycyclic aromatic system with near aromatic or fully aromatic stabilization. The fusion of additional rings compared to fluorine provides even greater delocalization and stabilization of the carbanion than in 9-phenylfluorine. This extended conjugation lowers the pK further than any of the other options. Moving on to the next step. Compare stabilization. B. pH to CH2, least stabilized, highest pKa, tilde 43. A. pH 3CH, 3 phenyl groups, pKa tilde 31. C. 9-phenylfluorine, fluorenyl aromatic stabilization plus extra phenyl, pKa tilde 18. D. Polycyclic fused system, maximum delocalization over the extended aromatic framework gives the most stable carbanion and thus the lowest pKa among the 4. And for the final step. Why other options fail? A. Only 3 phenyl groups with no cyclic aromatic carbanion stabilization, less acidic than C or D. B. Only 2 phenyl groups, least acidic. C. 9-phenylfluorine is very acidic, but the additional ring fusion in D provides even greater carbanion delocalization. Therefore, the correct answer is D. Therefore, the correct answer is option D.